Welcome to video 9 of tasks in Scala. Today we're going to be talking about logical operators and anonymous functions. Let me paste that right here. We're going to go over map and filter and pattern matching to repeat a little bit what we did before. So the task for you is going to be to collect important business information for the Choco Cafe from a list of sold products. Let's quickly go over what it is that you're going to do so you can get excited. That is all the stuff that you're going to learn. If you have a list of sold products, you're going to determine first how many products from $1 and up have been sold on a particular day. 2, what products did a specific customer have on a specific day. And then 3, for a given price range, what products were sold. Then we're also going to do some other stuff like convert the sold product information to a list of tuples. And then we're going to create from that list of tuples a list of strings. But I'll give you the details later. Let's just get started with the logical operators. Logical operators. We're going to start with a list of fruits. Apple, banana, kiwi, lemon, and pineapple. Now, for example, what we saw in the last video, what we can do is get the short fruits that have less than a certain amount of letters. So we could do it like this. We take out the fruits of which is size is smaller than 6. Let's print that. So this will give us the list of apple, kiwi, and lemon. That's correct. Now what we can do is, for example, grab the medium fruits. So we're going to do this with a filter, and we're going to say, well, we want to have all the fruits of which the size is smaller than 6, and we do that with 2 of those and signs, and the size is larger than 4. Then we call it medium-sized fruits. So I'm gonna print that so you can see it. And it gives us only apple and lemon. So let's write that down. Double and means and with a D. Now let's say I want to grab all the fruits that have either a really long or really short name. So I'm going to call that super short or long. And those are going to be filter the fruits that have a size, let's say, smaller than 5, or, and I do that with this sign, size larger than 7. Let's print this. Super short or long. That's a cool name. And it gives us the kiwi because that's a really short name, and the pineapple because it's a really long name. So the double, what do you call that? Sticks? I don't know. Means or. Okay, so it says here if the size is smaller than 5 or if the size is larger than 7, then we're going to grab that fruit. And here it meant if the size is smaller than 6 and the size is larger than 4, so only if it's between those bounds, right? And then we have one final operator, that is the exclamation mark, and this means not. Let me show you an example. For example, we have the Boolean it is hot, which is definitely true right now, and then we can have the Boolean it is cold, and we say, well, that is the opposite from the it is hot. Okay, so this means that if this one is true, it becomes false, and if it's false, it becomes true. Let's print that. It is cold, and it gives us false because the it is hot was true, and this is exactly the opposite. Those were the logical operators. Now let's look at some mapping and filtering over objects, because until now we haven't really been looking at that. So we're going to create a case class for this, which is a book. Then we have some sort of code. We have a title. We have an author, which is a string, the year, and a genre. Great. Now I actually prepared a whole list of books. You can pause it and copy this all. What I did was define 7 books with all of their information. The first one is from Jen Sincero, You Are a Badass. Second one and the third one are both from Eckhart Tolle. Then the fourth one is from Tim Ferriss. And then I added 3 books about Harry Potter written by J.K. Rowling. And then I made a list of the 7 books. So now we're gonna do some fun stuff on the list of books. For example, get all the books for a certain genre. So we're gonna create some functions. Get books for genre, and this will take the genre as an input, and it's going to output a list of books. And what we're gonna do is simply filter over the books, and we're gonna grab all the books for which the genre is equal to the genre that we got as an input right here. And you can see that I actually wrote this function as a one-liner. This is exactly the same as putting this between brackets like this. Okay, so I'm just gonna put this back because I quite liked how clean it looked. And let's print some examples. For example, get books for genre self-help. Print it. And we get the list of You Are a Badass and the 4-Hour Work Week by Tim Ferriss. That's correct. Now let's try another genre. For example, fantasy. Because I know that the Harry Potter books are all fantasy books. And then you get the list of all the Harry Potter books. Next, we're going to create a function in which we grab all the books between a certain range of years. Okay, so get all the books from year X until year Y. Let's create the function. Get books in range. We're going to get some sort of start year, which is an int, and then the end year, which is also an int, and the output is going to be a list of books. Now I think this is going to be a bit longer, so I'm going to put it on the next line, but still I don't have to use the brackets. So we're going to filter all the books of which the year is greater or equal, and then Scala will make this sign. So I don't know if you saw what I did. I had the greater than sign, and then I wrote the equal sign. If you put them together, Scala makes this fun symbol of it. So it has to be greater or equal to the start year. That means it is within the range, and also the year has to be smaller than or equal to the end year. Okay, so once again, this is composed of 2 symbols, but Scala makes a beautiful thing out of it. Let's test this. We're gonna get books in range from 2000 to 2010. Oh, that's 200. 2000 to 2010. It gives us a book from 2005, one from 2003. That looks pretty good to me. Let's take this a step further. Now we're gonna get all the books from year X until year Y for a certain author. We're going to create a function that's called get books in range. We're gonna create the function then that's called get books in range for author. And then once again, we give a start year. And an end year, and also the author. We're gonna return once again a list of books. So we're going to filter every book for which the year is greater or equal than the start year, and the year is smaller or equal to the end year, and the author is equals to the author that we received as input. Let's test this. I'm going to copy the name just to be sure. And we're going to say 1919 till 2000 for Eckhart Tolle. And it gives us only the power of now from 1997, because the other book that was here is from 2005, and that does not fall within the range. So that's good. The next thing we're going to do is map the list of books to a list of tuples. We're going to create a list of tuples with only the author and the title of the book. So I'm going to call that authors and titles, and I'm going to map over the list of books, and for each book I'm going to take the author and the title. So we're not doing a filter, because for each book in the list of books, we want to create one tuple. Let's print this. Authors and titles. And here you have it, a list with only the author and then the title of all the books. Let's do another one. For example, the titles and years. So we map over the list of books, and for each book we create a tuple that first shows the title and then shows the year. Let's print that. Titles and years. And once again we get a list of tuples with first the title and then the years. So you can easily create a list of tuples like this. And now we have practiced a little bit with the mapping and with the filtering, combining it a little bit with the logical operators. And the next topic is going to be anonymous functions. They are also called lambda functions, and this is actually nothing new. I'm just explaining to you what the name is because you've actually been using them already. Let me show you. First, we're going to check out the so-called normal function, times 2 function, for example. We would get an integer as an input, there would be an integer as an output, and what we're going to do is say, well, we're going to do the number times 2, because this is the times 2 function, right? A simple function. Now let's say we have a list of numbers, 1, 2, and 3, and we want to have all the numbers times 2. Now what we can do is we map over the list of numbers, and for each number we're going to say number times 2. Let's print that. And it gives us the list of exactly that. Actually, what we did over here is the same as what we did over here, but we didn't use this. I just showed this, right? So this is actually called an anonymous function. And this is a function that has a name, and we have defined the input and the output and everything. And this anonymous function, this lambda function, you see that it's kind of sort of on the fly. We've been using this all over, right here and over here. So you actually already know what it is, but now you have a name for it. So it's called anonymous function or lambda function. You can actually make it even more short. Let me show you with the times 2 again. We're going to map over the list of numbers, and for each input I want to do it times 2. So what I can write down is underscore, this is the input, times 2. This then is interpreted as the element that we're mapping over. Let's print that so you can see that it actually gives the same result. Times 2 again, and it's exactly the same. This is exactly the same as this. It's just a different way of writing it. The final thing we're going to do is mapping and filtering on tuples. To practice that a little bit more, we're going to start with some drinks. Once again, I'm just going to copy the information that I already wrote down. I wrote down 5 different drinks: frappuccino, 2 coffees, a latte, cappuccino, and then I just created a list with all the drinks. So I would recommend that you pause the video and write this down, because as always, I definitely recommend you write along just to get the practice in. Let's say we want to get the caramel, how do you write it? Caramel drinks. So I'm going to take the list of drinks and now I want to do some filtering on it. So I say, well, I have a tuple, and then on the second part of the tuple, so remember that we get that by doing dot underscore 2, I want to check whether it's equal, oh, I cannot write caramel, if it's equal to caramel. Let's print this, caramel drinks, and it gives us the coffee caramel and the cappuccino caramel, because those are the only two. We can actually also write this differently, so I will do the caramel drinks again, and we're going to filter over the drinks again, and this time we're going to use that underscore method. So I say underscore, which is the input, which is the tuple, right? And then I grab the second part of the tuple and I'm going to test whether it is equal to caramel. And this will give you the exact same list, caramel drinks again. Ta-da! It gives us the same thing. So this is just a matter also of what you prefer, but on tuples, I even prefer a different way. Let's find out what the regular drinks were. Regular drinks. We're going to filter from the drinks all the drinks that have the flavor regular. This code is going to be multiple lines, so I'm going to use the curly brackets. And what I'm going to do is pattern matching on the tuple. So I'm going to say, well, I know that this tuple is going to have some sort of product here, but I don't care about that. But I do care about the second part, which is the flavor. And then I'm going to say, well, is this flavor equal to regular? Regular. Okay, so this whole pattern matching, what we have practiced before, you can also use that in the filter. So let's check what this gives us. Regular drinks, and it gives us the regular coffee and a regular latte. But we can actually write this in a much more convenient way. Regular drinks again. Because as you can see, this is kind of, cumbersome. We have the tuple and then the tuple match. And the nice thing about these anonymous functions is that we can write it as follows. We're going to take the drinks and we're going to filter. And then we can immediately say, case whatever we had was something that we didn't care about, then the flavor. And then we checked whether the flavor was equal to regular. So you can see that you can just leave out this first part because the compiler will immediately understand what it is that you mean. You mean that you want to match the input to the case. So that's very convenient. Let's print this first so you actually see that it's the same. Regular drinks. Again, let's print that. And it gives the exact same output. And finally, some mapping on tuples. Let's say we have some pets. Once again, we have Oli, who you already know is a cat. Then we have a second pet, which is Sami, who is a dog. And then we have a final pet that I have invented, who is called Tweet, and it's a bird. Let's create a list containing these pets. Pet 1, pet 2, pet 3. Now we're going to map over tuples, and what we're going to do is determine what kind of present do we want to get for each pet. So I'm going to call this list that we're going to get the presents for pets. So what I'm going to do is map over the pets list. This is going to be multiple lines, so once again I do it within the curly brackets. We're going to have two different cases. One case is when it's a cat and one case is when it's not a cat. So the first case would be, well, the pet has some kind of name, and then if it's a cat, the cat would be written in the second part, and then I'm going to write delicious fish for name of the cat. And the second case would be that we have some name and then something, which will be other than cat. Oh, I see a double thing there. But we don't care about what it is. And then we're going to say a nice toy for name. Oh, for, not fro. For each pet in the list, we're going to do a mapping to this string. So this will be a list of strings. Let's print the outcome. Presents for pets. And then we have delicious fish for Ollie, a nice toy for Sammy, and a nice toy for Tweet. Here you can see an example of how to map tuples to strings. So you can really just map whatever you want to whatever you want. Okay, that was all the content. Now let's go back to the task. And let me give you a little bit more information, not that much. We're going to start off here. Your task is to collect important business information for the Choco Cafe from a list of sold products. Here I already wrote down what the case class for sold products is going to be. So every sold product will have the information about the day, the flavor, the base product. So one complete product consists of the flavor and the base product. For example, a chocolate cappuccino. Then you have the customer name, and then you have the price. And you will have to create at least 7 class instances, which means objects, of sold product, and then put them into a list so you can test whatever comes next. Okay? So then you're first going to answer those 3 questions that I talked about in the beginning. So how many products from $1 and up have been sold on a particular day? Now you know how to do that. What products did a specific customer have on a specific day? And for a given price range, what products were sold? So these questions, it's very important that you read them very well and you understand very well what are the inputs that will be given and you will have to use within the function. Okay? So on purpose, I do not just say like, this is the input, this is the output, but it's a little bit of a reading exercise as well, because this is the reality of how you're going to get the information. Well, probably it's going to be even more vague, but okay. We're still in the practicing phase. Then convert the sold products. Oh, this is a double the. Convert the sold product information into a list of tuples. And the tuple is going to be the day and then the full product name. As I said, the full product name consists of the flavor and the base product. So for example, you would have Monday and then caramel cappuccino. Okay, so you have to map all the sold products to a list of tuples. And then finally, from that list of tuples that you have over here, you're going to create a list of strings. For the products that were sold during the week, you're going to create a string that is something like this. On Monday, a caramel cappuccino was sold. And then for products in the weekend, you're going to write a different string. It doesn't have to be exactly this, but you get the idea. Weekend purchase, chocolate frappuccino. You're going to be able to use bits and pieces from this tutorial and put them all together. Well, have fun, and I will see you in the next video.